So relations and functions are also called direct variation, and I'll write that right there. Direct variation. And that'll make sense in just a second. Before we understand that further, I want you to understand a couple of key vocab terms here. So first we talk about a relation. A relation is a set of ordered pairs, meaning like an x and a y coordinates, right? Like we're going to go graph something on the xy plane, we would have our x and y coordinates. So that's a relation, that's a set of ordered pairs. A domain is our first coordinate of the relation, so there's our x, that's our domain. Our range is the second coordinate, which is the, you guessed it, y. Finally, a function. A function is where each member of the domain is paired with exactly one member of the range. That'll make sense in just a second when we test it out. Okay, so on the previous slide when I talked about a function, meaning that every domain is paired with exactly one member of the range, I'll show you what I mean that right here. So I have a set of, what are those called? I have domains and ranges, and when they're together, that's a relation. There we go. Now let's see if all of these are a function. So domain, 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 and we have range, 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 range. So let's write the domains down. So we have 0, 1, 1, and 2. And the ranges, we have 1, 2, 3, and 4. And you understand what I did there, right? 0, 1, 1, and 2, those are our domains. 1, 2, 3, and 4 are our ranges. Now let's partner them up. Okay. I have 0 goes with 1. Great. Now for my second set, I have 1 goes with 2. Great. Now for my third set, I have 1 goes with 3. And then I have over here 2 goes with 4. Now that looks like it makes sense, but what's wrong here? Right here, 1 is the same number, meaning this 1 is actually the same number and it goes to a 2 and a 3. I spaced them out to kind of trick you a little bit, but you should realize that I could just redo those and say that's just 1, 1, and it would go with both this 2 and this 3. Make sense? I'll show you another one. What that means is that this is not a function because this domain right here is partnered with more than one range. I'll show you another. So I've got a bunch of ordered pairs right there, and there are relations. Now I'm going to see is if these 4 are a function. So I'm going to write them out. So the first one, the domain is 0, and the range is 1. For the second one, the domain is 1, and the range is 2. For the third, the domain is 2, and the range is 2 also. And then for the fourth and the final one, the domain is 3 and the range is 4. Now you can say, well, why didn't I put this one again? And like on that last slide, I didn't put it twice because it's still the same number as this. So these 2's are the same number in this range, okay? Now let's partner them up. This 0 goes with this 1. This 1 goes with the 2, and this 2 goes with the 2, and the 3 goes with the 4. Now what I want to ask you, does each domain have one specific range? Remember we said that it's a function if each member of the domain is paired with exactly one member of the range. So, is this? Now I know you're about to say, well, these two go to the same range, but think about what I said. It says that each domain has exactly one range. It doesn't say that they can't be the same range. It just says that each of these has the same. So this is actually a function. Yeah. Another way to think about the domain and range kind of problem there is that if you have an x, it has to have a specific y. You can have, we'll call this x1 and y1. If I have another x, so x2, but it has the same y, that's okay. But I can't have x1 again and then do y2. That'll make sense if you look at like on a line. So right here I have my x values and my y values. Let's say that this x1 was 3 and the y1 was 1. Let's call our x2, let's do that at the point 4, and our y1 has to be the same number, which is 1. Now let's do x1 as being, which again was 3, because originally that's what I said right here. But now let's put in a different value and call that y2. If I try to graph these, the first set, I would say go to the point 3, comma 1. So I'd say 1, 2, 3, up 1. So that's right here. Now for the next one, I'd say it's at 4, 1. So I go 4 and 1. There it is. Now for the third, I'd say 3 and 2. That means it's right here. What I'm saying is that think about your input and your output. If I look at my x's, we know our inputs, and our y's are our outputs. Remember, x is always input, y is output. If I put in the same input, say 3, meaning like I worked for 3 hours, I should get the same thing every time, right? If I get paid an hourly rate of, let's say, $10 an hour, for 3 hours, I should get the same amount no matter what. I can't say, well, one day for 3 hours I got this, for another day for 3 hours I got more. That doesn't make any sense. That's something different. That means it's not the same value, and that doesn't work. However, I could say that one time for 3 hours I got an amount, and another time for 4 hours I got the same amount because it changed. Okay, so let's determine if this relation is a function. Remember what I said, each x, or each domain, has to have a specific range, or a different y. So we have, if we look at the first one, we could say there is -2 is partnered with 3. Then for the second one, we have 2 is partnered with 2. Then the third one, we have 2 again is partnered with -2. Now remember, these two are the same, so it's like saying 2 is, the 2 for our domain, or 2 for our x, has two different ranges, or two different y values. So no, this is not a function. Let's try that one more time. Let's do this one. I have -5 is partnered with -4. I have 0 is partnered with -4, which again I'm going to say is the same number. And then we say 5 is also partnered with that -4. So all three of these x's, or all three of these domains, go to the same range. Is that a function? Answer is yes, it is. When you're looking at that kind of confused, understand that each of these are different and they can go to the exact same value. It's when it's the other way, it was when it's the same number, like for instance if I said -5 and then -5, and they both went to different numbers, like 2 and then 3. That does not work. Over here, I have different x values, or different domains, going to the same range. I know that's kind of confusing now, but when you start graphing them, it'll make more sense. So like I was saying, when we graph them, it'll make more sense. So here we have our domain, or our x values. Over here we have our range, which are our y values. If I wrote them out as ordered pairs, we'd say -4 and -3, 2 and 0, 2 and 3, 4 and 3, 5 and -4. To graph them, -4, -3. So I go x -4, y is -3, boom, is right there. The next set, 2, 0. I go x is 2, y is 0. Done. Next one, x is 2, y is 3, is there. Finally, 4 and 3. And then lastly, I'm sorry, the last one was not finally, but this one is 5 and -4. Okay, is this an ordered pair? I'm sorry, is this ordered pair a function? Now you could say that these two right here have the same y value, and these two have the same x value. Does these two having the same y value, or these two having the same x value, make it not a function? The answer is it's these two having the same x value makes it not a function. This is okay. This is a line. This does not count. This is actually breaking something called the vertical line test. Meaning, if I were to say take like a pencil or draw a straight line, pretend this is straight. If I were to do this as many times as I want, anytime you have a point that lies on a vertical line as the same, some another point on that same vertical line, that is not a function. So you see right there, those 2 points lie on the same vertical line, so therefore they are not a function.